As we're wrapping up this part of the energy unit, we have a few terms that we need to still define and go over. So this will cover those miscellaneous items, concepts, formulas, terms, things that we need to cover before the test. Friction is a force that really moves opposite to the direction of the motion of an object. So what that actually means is that you have something, maybe sliding or rolling or pushing, whatever, past a surface. Friction is that force that's moving in the opposite direction. Okay, so for a falling object, something that's falling through the sky, the air pushing back up is the friction, air resistance or air friction. If you have something sliding across the surface, that surface that it's sliding across creates friction. Now remember back when we talked about law of conservation of energy, the fact that energy is not created or destroyed, it's just changed or transferred. So when you have a moving object with kinetic energy and it slows down, it's slowing down because of friction. Okay, so what happens to the kinetic energy? Because if all of the energy is always the same, the kinetic energy should be the same. But because of friction, that slows down a moving object. It also creates heat. So there is an energy transfer from, in this case, kinetic energy to heat energy. Friction is not a type of energy, but it's what slows something down and causes the energy to be changed into heat energy. So since we're talking about heat energy or thermal energy, what is heat? Well, heat is thermal energy that flows from an object at a high temperature to one at a low temperature. So what that really means is that when you're talking about heat flow, hot moves to cold, or higher energy to lower energy. So when we're talking about that energy, the thermal energy, what we're really talking about is temperature. Temperature is a measurement of how hot something is, or the measurement of the hotness of an object. This is related to the average kinetic energy of all of the molecules that are in that object. Thinking back, you've learned that all substances, all matter is made of molecules, atoms, particles that are constantly moving. Well, the faster they're moving, the more kinetic energy they have. The more kinetic energy they have, the higher their temperature. Those temperatures can be measured in degrees Celsius, Fahrenheit, or Kelvin. Now remember, Fahrenheit is on the English scale, right? Celsius is what they use in Europe, England. And then Kelvin is the scale that uses absolute zero as the lowest possible temperature. So on the Fahrenheit scale, just kind of a side note, water freezes at 32 degrees. On the Celsius scale, water freezes at 0 degrees. And on the Kelvin scale, water freezes at 273. Energy is measured in joules, but when we talk about heat energy, we also use something called the calorie. 1 calorie is the amount of heat that it takes to increase the temperature of 1 gram of water 1 degree Celsius. The calorie that you're familiar with on like the back of a food label is actually a kilocalorie. A kilocalorie is 1,000 calories. And usually it's just written as calorie with a capital C. And like I said, this is what we use to measure the energy that we can get from food. Specific heat capacity is the amount of heat that it takes to raise the temperature of any substance by 1 degree Celsius. Since specific heat capacity is the amount of energy that's required to raise the temperature, joules is our energy unit, so it's going to be joules per gram, because that's the mass of a substance, degree Celsius, because we're raising the temperature by 1 degree Celsius. So joule per gram degree Celsius is the unit, and different substances have different specific heat capacities. So something like air has a specific heat capacity of 1.01 joules per gram degree Celsius. And something like water has a specific heat capacity of 4.179 joules per gram degree Celsius. So what that really means is that it takes a whole lot more energy to increase the temperature of water by 1 degree Celsius than it does air. And that's really all that specific heat capacity tells us. So this whole unit is about energy. And remember, energy is the ability to do work. Well, what's work? Work is the result of a force that's applied to an object that will cause it to move or to change. Since work is applying a force to move something a distance, it can be calculated by taking force and multiplying by distance, or W equals F times D. As far as units for each of these, a Newton is the unit we use for force. A meter is the unit we'd use for distance. So newtons times meters is actually what gives us joules, and joule is the unit for work. When we talk about work, we also talk about power. Power is the time rate of work, or it is work divided by time. You can also calculate power by taking force and dividing it by velocity. To abbreviate that, P is equal to W over T for work divided by time, or force divided by velocity. So if you were trying to solve some problems, some calculations, and you were given force and velocity, you could calculate power. Or if you had work and time, you could calculate power. As far as units go, the unit for power is a watt. Work is a joule. Time is in seconds. So if you have work and time, it's joules divided by seconds to get watts. Or if you have force and velocity, it's newtons divided by meters per second to get a watt. Either one of those works. As far as the formulas for work and power go, it's going to be important that you know these formulas because we will be using them for some calculations later. Just to summarize all of the units that you need, I've put together this table. So SI units are listed on here for mass, power, temperature, and force, and then just some other units that you might need as we go through the energy unit. So take a few minutes and copy this table down. The last few vocabulary words are things that you need to know for your vocabulary test that you'll be taking. When we're talking about energy and natural resources, we talk about renewable and non-renewable energy sources. A renewable energy source is one that is used, but it's not used up completely. You can go back and get more, or it's generated quickly enough that it's not used faster than it's made. A non-renewable source, on the other hand, is a resource that is not readily replaced by natural means on a level that's equal to how much it's consumed or how fast it's consumed. And then consumption is just the using up of a resource.